Good morning. Welcome back to another episode. So, it's been a little while. I think between myself and the family, everyone's been a bit ill. I don't know if you can still hear it, I think my voice still shows it a little bit, but I think everyone's getting better now. So, just remind myself what we were up to. I think the next step is making things look a bit nicer. So, yeah, we've got something functioning, right? We can drop pieces. We've got a preview of the next piece. The score is shown and it works, right? And show the score working. There you go. So the score goes up. But it all kind of looks terrible. And the reason for that is that so far, despite having texturing all set up, we're only using textures for the numbers. So these fonts are drawn from a texture onto a quad. But the rest of these are all just hard-coded in like override colors. Which has worked for getting the layout and things working, but we want to be able to replace that with something a bit more nice. Now, I've not got any really fancy art, but I have got a little sprite sheet with some squares that I've drawn. So, if we have a look here, we've got, I don't know, how many is that? 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 colours. Yeah, that feels like enough. So, that gets us started. My hope is we write something that, oh my god, lets us sample from this sprite sheet and say, I want like red to mean this one, or color 2 to mean this one, and color 3 to mean this one. And then we can update this and replace with something nicer later if we really care. Oh my god, I closed Emacs, I'm an idiot. Okay. Now, I'm not actually entirely sure what's going to be involved in all that change. Where was that message that just popped up? Processing message, opening directory, no file directory. Okay, interesting. Sorry, hang on. So, we are going to want to first read our asset image. We could do it so that it's built into the executable, but I'm not totally sure how we do that. And I don't want to spend the time, so I don't think it's going to take like that long to read the one thing in on upload. So instead we'll just have the asset image there. We'll load the asset image, create the image on the GPU. It'll be a single texture, I think. I think what we'll then do is we'll have a array of samplers, one per I guess sprite, and yeah. Hopefully that works. That feels simpler than that feels simpler. So the other option would be we create a separate texture image per sprite. Maybe that is easier. I don't know yet. We'll see what we do. But step 1 is reading in our image, and we already do this for the font, right? So can I say in here, asset. That's probably a bad word, sprite. I think I call it sprite PNG. Sprite sheet. I don't know why it's complaining about this. Vertex buffer not found. Oh, okay, I see. Hey, get rid of that one. Egypt boy. Okay, So we have to try and be more conscious of that. I'm coughing and spluttering everywhere. What was I going to do? I was going to go look for where this is getting called. And we'll go from there. We have img load. Nice. Right, so what do we do for the font? We load thing, we blow up if it fails. Data size bytes. Size of one thing, first element times by the length of the data. Makes sense. I have a to do. I don't think I have to done. Okay. Think about that later. What are we doing here? So for B and index in data, if index modulo 4 is not equal to 3, we continue. So if it's not the alpha channel, just write it. Then we could have handling to say, oh, in fact, actually, that's doing nothing at all, is it? We are just looping over it for no reason there. Interesting. All right, let me go ahead. Oh my god. Yeah, that way around. And that way around. Comment that out. Comment that out. Grab that. That seems like we might still want to do it. What are we doing here? This is then sending that to... What's it? Right, okay. So we have a staging buffer that we're sending the data into. We do there. Then we create our image. Then we allocate memory for the image. Transfer destination barrier. Command pipeline. Buffer image copy. What are we doing in here? Setting the... I'm not sure what we're doing in here. We're doing the copy from the buffer to the image resource at the top of the pipeline, so it'll do it right at the start. I think is what that's saying. Buffer image copy, command copy that. Shader read-only barrier. And then we need to make the image into the right format. Well, that all seems quite a lot, doesn't it? Can that all be pulled out into a function? That we just pass the texture path and a pointer to the right stuff on the renderer. Create texture from file. Which will take path. Not sure what type you are. And what we actually call, we'd say here, create texture from file. Right, and we replace that with path. That with path. This wants a C string. Simplest, just make it a C string then. If not okay, image fatal is all of this guff. 3 at the end of the scope. Stop that comment. We've now not got access to the renderer. Best to just pass in our renderer directly here. So say renderer. We are pointed to the renderer. And in here we can do that. So the stuff it gets to update. That won't be enough though, will it? Interesting. So there's a load of stuff we need to read. Right, so there's a bunch of stuff like the device and stuff that we're going to have to read off the renderer. This should blow up somewhere because we're going to be writing to it like so. Is it only texture image memory that we're writing to? Interesting. Oh, I've left the scope now, haven't I? Bugger. I'm not sure how I feel about just saying I'm going to pass in the whole renderer because I won't know which field on the renderer I need to update. So I'm thinking what we might do, we might pass in the renderer for stuff to be read off. I think we have to do this little like shadowing trick to make it so we're allowed to what would the word be? I think that there are Vulkan calls that will need things like a pointer to the command buffer, which this will let us do. Right, actually, let's comment it out and see if anything breaks. So it reads it in. We create the staging buffer. We map the memory. We allocate the memory. We, at the end of the scope, we'll undo all of that. We do the copy. Create the image. It's 2D. sRGB. X and Y are from those earlier reads. Sharing mode exclusive because we're only using the 1Q. Visual layout undefined because it isn't known. Right, and then image create result. So that's the issue there. We could have it return stuff, and then you put it onto the renderer. That's an option. There's texture image, which is an image. There's texture image memory, which is device memory. I think that might be the neatest thing to do. So we pass in a renderer, but it's not a pointer, so you know that you can't use it. I'm saying here texture image is a Vulkan image, and texture image memory. Weird thing here, device memory. What does that look like then? We're still going to get images or issues because of this. So that I can now just do this. Sorry. So when you create the named return value, it will initialize at the start of the scope. So we can then just write to it, which is quite nice. We can do this. This way we have to be careful, right? Because that is now this texture image. If not, okay, failed to allocate and map texture memory, failed to begin. Calling texture image commands, transfer destination barrier. I don't think any of this changes. Buffer image copy. And those values are being read in from from our image load. Image offset. Nothing, so we just have the whole image. Command copy buffer to image, command buffer staging buffer. Texture image. Data read only barrier, image memory barrier, texture image. Pipeline barrier. All that stuff. And yeah, this is what I was saying, so we're going to have to do that shadowing trick so that we can actually get that reference. You submit device wait idle. Device wait idle might be overkill. I don't actually know if that's needed. Right. We see if you run. Oops, that's not a thing. Do not. We forgot to return. No. And then we need to put these rewinding. So renderer texture image, renderer texture image memory are equal to that. Still no. Image memory barriers dot image. Where are we doing that then? Command pipeline barrier. Memory barriers has transfer destination barrier, which is using that prematurely. There we go. Excellent. Cool, that worked. So let's grab all this and stick it down the bottom. In fact, can I remember the command? I think if you go to the bracket, and then I think that, no. It's a command to be like, I want to jump the end. That was previous. Next. On this one, that's next. That's previous. Right. I'm here. I start marking. I go to there. I go to next. There we go. We're getting the hang of this. Ah, texture image view. We'll probably end up needing as well. Okay, hang on. Pop you down there. We'll reformat. Check for errors. My god, there's a lot of stuff in this file now. Right, come back up to here. What is this? Should that just be lumped in with create texture from file? Quite possibly. Means that needs to go. Create texture image, renderer, texture image view. I think it might. Okay, so we're in here, grab that. in there. And then texture image view, it's angry about because we need to come all the way back up here. Say you could also return a texture image view. We expect some errors. Yep. So, see if that compiles. And it does. Beautiful. Alright, so now let's come up here and see if our renaming works well. We'll do it for you as well. Our font texture image memory. You are font texture image view. Recompile, because I never trust the OLS to actually do it right, but there we go. Nice. And then what we're going to have, so let's do like the same event. So actually, we can do this more cleverly, can't we? We go here, grab all of this, paste it in twice, not mess that up, and replace that with Sprite. Right. Back down, find our different things in here. What you want to be able to do is then simply say texture image, not font, sorry. Right, let's just do that again. Make that say sprite is equal to create texture from file. Oh, depth image. I remember. That's how we're doing our Z index checks. Run that and see if it blows up. If it failed to get the assets, it would blow up. But it doesn't. Alright, cool. That's a unit of progress. Right, I think this is where the world now gets more interesting. So we've got our image. What do we have to do? Do we have to make a sampler per sprite? No, because we're just going to sample from the one image. So I think we just need a second sampler. Info res gives you this sampler. Right. Now we pull that. Stick it in my little wrapper file. I dislike, it seems to ignore brackets. So here, if I'm like, I want to jump back a word, it skips over or not letter stuff, which really throws me every time. I'll have to, one day I'll sit and just do some proper fiddling. Ah. Does this want to live in this file? This file is kind of intended to be just wrappers and not opinionated. This is opinionated, right? Because we're setting all these values, and I want to set the same values each time. So actually, I don't think this file is the right place for this to live. Hang on. Let's head back to renderer. Pop it at the bottom as well. Remember my shortcut? Go. Get better. This, I think, probably wants to do the same trick. So it's going to take in a renderer, but not a pointer. Turn you. A texture sampler. And then you'll have to remember to put it on your thing. That. And then at the very bottom, it'll just turn what it had. Nice. And does not blow up. Let me go get this point in the code. Huh? Oh, it's in the diff. I'm an idiot. Let's go. Texture, image. In yeah. I'll create sampler. Renderer dot texture sampler equal to that. Check that renders. Yeah, so that would have blown up if we'd gotten it. Oh, hang on. Gotta run. Okay. Apologies for the jarring jump. I had to run away. It's actually the next day now. But we are back. Extra apologies. I think I've got a bit of a sore throat coming on. So if I sound particularly bad, I might end up having to quit a bit early. But keen to get this to somewhere slightly more sane. What were we doing? We were in renderer. We're working out how we want to do our sprites. I think I left it to do. I did. Right. Do I have a sprite sampler? I do not. Right. Let's do this then. Rename you. And then we'll make sprite one. I think I need to learn more about how this jumping forward and back stuff works in Emacs, because it only seems to work for me like half the time. Or I need to find something a bit kind of like harpoon or something. I'm finding, particularly within a file, being jumped around a lot. Okay. Less efficient. Okay, so we now have two samplers, which means actually what does that mean? Um, I think it means our drawables maybe need to include something to say which sampler they care about, right? So where before we just had to pass in vertices and indices. Well, I guess we're still going to only pass in vertices and indices, but our vertices, I think, are going to have to include something to say which sampler they want. What have I got that all wired up at the minute then? So our current vertices, position, color, and texture coordinate. That's interesting then. How do I guess you have to bind a sampler, don't you? How would that be? Rename this one, because you're now the font texture. Bind sampler thingy. Now, one thing to say is very clearly, we can simplify this by just having the single sprite sheet, but I think it'd be useful to be able to have multiple sprite sheets. The kind of thing I've got in my mind is it might be nice to later on allow you to swap out the kind of game aesthetic sprites, but keep menu sprites in a different sheet so that we can guarantee that you can still get to the menu and change stuff. It's the kind of stuff I've got in my head. So this particular example might be slightly contrived, but I also don't really want to sit copying my font over to another PNG. Descriptor type, descriptor count, immutable samplers. What actually points to our sampler, though? Okay, let's just keep plowing on. See how we go. So descriptor type. Let's combine image sampler. Descriptor count 1. Can I just put a descriptor count 2 on there? We do that. We bind a single descriptor set, but that descriptor set has 2 combined samplers. Allocates the memory. Then in here, what are we doing in here? Writes descriptor set for descriptor count p image info. So I think let's say font. Lies. Image view, image layout. Update descriptor sets. Am I just being really dumb? So that only has... Oh, no. It has the sampler and the image view. Yep, I've got it. Yeah, okay. So that's our font descriptor image info. So I was right. We come in here, make use a font. We'll make a sprite. Descriptor image info. This makes sense, right? We're making a new thing that needs to be accessible within a shader. So we have to stick it in a descriptor set. And it will have a sampler. And we should have an image view. Sprite, texture, image view. And we want an image layout. Be that same thing. Because we have the fence earlier that makes sure that happens. Or the memory. What's the word they use for it? Some sort of, it's like a memory boundary or something. And then we're going to say here that there's 2 of those. Destination set. Destination binding 0. Destination array element 0. Descriptor type. Sampler descriptor. Images. One of them and one of them. Cool. And then instead of a pointer to the one of them, there's a pointer to the pair of them. And because it's a slice, we can't do it like that. So we would do raw info. Raw data, is it? And then we do the update descriptor sets. Do you compile? No. Trying to allocate 2 descriptors, but this pool has a total of 1 descriptors for this type. Might succeed on some implementations, it will fail on others. Interesting. So, does that mean our allocating is not doing what we want? Create descriptor set layout. We then have a single descriptor set like that. Hang on. Am I misunderstanding what right descriptor set is doing? I was like, that must be right. It is a single descriptor set. Only pnex left on there. So I thought that's saying that we are going to allocate 2. Binding count bindings. My God, I'm confused. Okay, where are we looking? Let's read the whole thing. Trying to allocate 2 of this descriptors from VK descriptor pool, but this pool only has a total of 1 descriptors for this type. While this might succeed, it will fail in others where descriptor type combined image sampler is found in the pool P, pool sizes 0, descriptor count 1. The allocations are being requested. Okay, so where's P pool sizes being set? Oops, pool sizes. Oh, hey. Cool. So I think at that point, we have bound a single descriptor set that has two descriptors in it, which are our two what's it called? Textures. Right. This would be useful to have that jump back to where I just was button. Go find uses of view. Where are we up to? Description set layout is created here. Allocated is updated. Then it'll get bound in this, I think. Descriptions is different. There we go. We create this thing, it has that set layout. Where are they bit bound? Blend, render and create. Depth stencil. Done inside draw frame. I think I called it render frame in the end, didn't I? Copies in. Previous frame finished. Get the next swap chain image. We bind the pipeline. Bind descriptor sets. Single descriptor set. No offset. Then we draw. Okay, so that sounds good. I think that means we are set up to be able to access it. Oh. Okay, so we have to remind ourselves how to do GLSL now. Where our shaders live. Okay. So I think I've hit this before. Layout binding equals 0. Uniform sampler 2D. I think really this is now a list of samplers, right? Something like that. I don't honestly remember. Like that. Texture LOD, no matching function. Oh my god, broken things. What did you do? There we go. So now what we have is two samplers available to us. They're both bound to the same descriptor set. So I think what we have is we have to put something like that in there. And then we're going to need an index, which will need to be passed in per vertex, so this texture coordinate knows which sample, which what am I saying? Which image it's sampling out of. Which I think means what we actually need to do, we need to go in vertex to add like a texture index. Is there a GLSL int? Float? No. Just make it an int. Does that stop things building? It does. Oh. Looking at this thing, draw drawables, for drawable in all of this stuff, which means we need to go and say drawables now need to know. Which integer? Which, what's it they're using? Alrighty, what is that blow up? Online 90. To view values in structure, literal expected 4. Vertex buffer is equal to what's hyper-U? Vertex with those things and draw. Texture data, text X. They're going to be that on all of these. I think. Cool. And it's 0 everywhere, so nothing changed. Good news, because shouldn't have changed yet. Sorry. I find everywhere that I've got draw underscore. This is where our change needs to come. So in here, as we're doing drawing, where do we put these indices? Where do I put my constants? Sprite, path. No? It was at the top of renderer. Yeah. Font, texture, index. 0, sprite, texture index. 1. Right. So can we go back to, I think it is in here, isn't it? Draw, entity. Let's have a look at draw button. Draw rect, draw string. Okay, draw rect wants to actually have. Do we want to be able to pass texture data through on you? Makes it much messier, right? Okay, we'll leave draw rect as it is. You, sir. Just do that everywhere. That should then compile and work exactly the same. Because nobody's using it yet. Right. Where's draw grid then? Draw grid. Draw grid cells, which gets dimensions. Color that's going to be different. We can no longer do draw rect. In those. What I want to do. Okay, let's try empty texture data. Base of 0, 0. Dim. I think I made them 32 square. Going on. So that I think should point to the first thing in our. What's it? And that should point to the second one. So then, instead of draw rect, I have to say like draw sprite. Or texture data. Build else. Empty texture data. Should we go with that? And then instead of draw rect, go find. There we go. Okay. Do draw sprite. We'll have a texture data. Pos, dim, Z. Like so. Actually, that all looks the same. No color. Texture data instead. Do that. We see nothing. That's because we're passing it in texture data. Why is that? Because I'm passing in texture data that points to nothing, I guess. But currently it should be using the stuff off the font sheet, right? So I'd have expected to see little chunks of numbers. Maybe that is concerning. Draw grid cells. For each of these things, take texture data. We'll put our override colours back in. That works. I think we're confident. So we have override colour true. So that all vanishes, and if I come back in here, I say true. I say red. We see a load of stuff. Good. Ah, damn it. We might want to be able to pass through a colour to debug, might we? Damn. Pass through a ball and a debug colour. Like so, and that should fail to compile. Because up here. Empty debug colour. Which will be, I think I've been doing blue and red, haven't I? So let's go blue. Build. Debug colour. That can be red. Come in here. That can be false, and then empty debug color. That will split it. That should still draw nothing. Then we flip that to true, and we get back to our blocks, and it all works. Cool. That's nice because that at least lets us see the quads that we're drawing. Now you'll notice. Oh, I was going to say, notice that our blocks aren't doing what we expect, but so this isn't a single quad that's being drawn. This is a grid of quads that's being drawn. So this is made up of lots of little squares. So yeah, well, actually it does work. Okay, that's nice. So we'll undebug you. And then all that's left to do is to actually wire up the renderer chunk. But before I do that, I'm going to run to the loo. So 1 minute. Alrighty, I am back. I assume everyone's like that. I just can't think straight. Where were we then? Right, so we're now shunting through that we would like to use the other sprite sheet. We have the other sprite sheet wired up. Just need to work out how to put that in our shader. In yeah. Now, can I do this? Like, there's two of them. Actually, then just pick the first one. No, text sampler is not defined. That's doing the same thing. And we know in here that we actually have more information. First, you compile. No, unexpected identifier expecting semicolon. That's something I'm not doing inspected in my vert shader. Oh, sorry. Shaders. Input attribute descriptions. Should put this on here, shouldn't I? Vulkan, vertex, input, attribute description. Finding 0, format. It'll be a 32 int. Set cast U32 offset of what do I call it? X. This thing. Doc. Syntax error, unexpected identifier, left brace or comma back in our main.frag. We're doing wrong. So 0, 1, 2, 3 is pos color, texture coordinate, and texture index. We want to handle it the same way we handle the color, which we notice is being passed in there. Probably means that in our vertex shader, pass it through. We go layout, location 3 in I32. Might not be called I, it might be called S, I can't remember. In texture index, layout location 2 is an out I32 texture index. Write it. Like so. Back to the frag shader. It now has a texture index. It should be able to read in. Is it not called I32? Is it called S32? It's just called int. God damn it. Okay. GLSL integer types. Basic types, scalars. Int. Uint float. Yeah, it is int. Cool. And then again, you're an int. Int must be qualified as flat. What does that mean? Say in here, flat. GLSL flat int. Not a one-to-one mapping between a vertex and a fragment. By default, this thing using the flat keyword, no interpolation is done. Every fragment generated during the rasterization of that particular primitive gets the same data. I see. Okay. Cool. So we're doing this. Now pass in texture index into there. Oh, hey. Right. We'll have to look at our textures I drew to see what we expected to see. I can't remember. But I mean, that's looking at least moderately successful. Right, but we are seeing all those artifacts. I think I know what's causing them because I've hit it in a previous little project I did. We jump quickly to Bracky and we go look at its fragment shader. There's a little thing I have found here. Am I doing the exact same trick that I was doing before? Oh, interesting that the thingy 3's on the other side. I've done that wrong. Well, first thing I want to say is this I think we're going to need. So, uniforms are expected across, what do you call it? Like they call it a wavefront. I've got that in my head. Across the batch of calculations being done in parallel, it expects that the uniform always has the same value, and it will then take that assumption and make optimizations to its memory layout. Which is fine, except for we've made it not uniform because depending on the value of this thing, the value of this thing or its output will change, which can cause the kind of glitchy artifacts that we were seeing in that other one. Can I actually split this? Put my other thing in here. So this is Bracky, which is a previous thing I'd done. What did it do? Texture LOD. That was it. You just put non-uniform around this bit. So that tells it that you can make that assumption everywhere except for this reference, and that limits what it can do for its memory optimizations. Save Bracky platformer. I should make any changes in Bracky platformer, should I? And we see all the glitchy bits have gone. It's still not necessarily looking how I expected. So maybe it's worth a quick look. I'm slightly unsure. Why have I got it there and they've got it there? Does that make a difference? No. Cool. Shall we go have a look at what our actual... Are these two doing exactly the same thing? They might be. Ah, no, our thing has this override color little addition. Then this looks like it's basically the same. And then our window transparency handling. Yeah. Fun. Let me have a drink. Okay, so we shouldn't need that anymore. We're in here. We want to go and have a look at our assets sprite sheet. Excuse me? Oh. That one. No. That one. We see red and we see green. Which is a good sign. Now, the one thing I was expecting was I've made the edges dark, which I thought we would be able to see quite easily. But we can't. So one possibility is that I've got the sizes of these things wrong. right? Like we should see like little boundaries within these. In fact, actually, this is almost one-to-one sizing, right? So they should basically look exactly like this on here. But they don't. How do we work out why? I might open it up in Critter and just check. What size have I said that they are? Where did I actually write all of this stuff? It seems drawable. Get this texture data. Set base to 0, 0. Dim 32, 32. What does that do? Does it turn it black? It just misses. Ah, okay. What are we just missing? I think I know what's happening. Almost always for this sort of thing, the top left is your origin, but and that's true. Oh, it's confusing. So base to match the way that we're reasoning about our quads everywhere else, I'm treating the base as the bottom left corner, but I was just passing in the top left corner. So I guess what it was doing is it was taking this point, then trying to reference points that were off of this, and it didn't work, so it just stayed taking these two input points, I guess. Oh. I can't remember what I've done for my like wrapping behavior, but that's good news. So we know what we were doing wrong. Use look like that, and we get squares. It looks kind of bad, but proof of concept, we can indeed draw textures. I honestly think it looks worse than when it was just flat colours. But the point is, let's lose the game so it stops. The point being, we can now draw whatever we want onto these. So we can start making the game look nice. The same's probably true as well for like the side panel. Or I think the side panel might just want to have like a line down the side of it that we can now make a texture so it looks nice. There'll be a bunch of stuff we can do. But hey, that works. So, what have we learned? We can now use multiple sprite texture inputs. So, that is fun. I think that might be where we get to today. Because it's another busy day. But I don't think that's bad going. Shall I just sanity check the diff? I guess one thing that we're going to want to do is update pieces. Okay, hang on. Okay, so sanity checking this. Let's go commit you. And I'll say here, allow drawing sprites from different input. Or from different textures. So that's our successful bit of progress, because progress keeps the project alive. And let's nip to the README. That's kind of done. We don't have assets for it yet. Oh, what was I saying? So we've now got the plumbing in our renderer to enable that. Update piece to include, so individual cells are not empty or filled, but empty or cell 1 or cell 2 or ... So we can apply different texture for each cell. And then we can mess with that as much as we need to make it look nice. You can kind of imagine as well, we might end up having like little subtle animations on the cells if that makes it look nicer. Alright, so it might be that cell 1 in the first instance is like red, and we do something to try and make it look nice. But if it still looks too boring, we might have it so that like every, I don't know, 2 seconds it kind of twitches slightly. And so it actually has 2 or 3 different sprites in our texture that it will refer to, and we'll have like a ticker to move between them. But none of that's too hard. Yeah, we've still got kind of tidying, refactor type stuff that probably needs doing at some point, but we're not feeling particularly slow yet, so that's not a problem. Cool. I'm quite happy with that. Let's push that up. Update README. And then we will work on that piece thing next time. So, if you've made it this far, I hope you've enjoyed your time, and I will see you on the next one.